Yeah.
Cool.
So the first thing on the agenda was the suggestion that this meeting, I mean, it's nearly in person anyway, but the suggestion that we have Mesosphere external people kind of more formally invite them to Mesosphere every other meeting for like a 2-hour sync up that Ben H suggested. So we would still broadcast it by Zoom, but yeah, it would just be a chance for people to kind of all sit in the same room and talk about various topics. What do you guys think about that?
We kind of used to do this, right? We used to have the afternoons where 3 or 4 hours people would come together and hack on stuff.
Oh, so you're talking about the work group as opposed to the dev meeting? Or?
Well, just combine them basically. So we would have, let's see, what would it be? Every other meeting. Yeah, so I think we used to have every Thursday. It used to be an afternoon where people would come together. Eventually it sort of, I don't think it was as coordinated. I mean, we could do every other. We could also do like every third. We could do every fourth, but it's just a general idea. Like, I think too much, then people aren't going to do it. We need just the right amount. So people are like, you know what, I'm willing to actually drive someplace, sit down with other people, work on some docs or write some code or like work on a design doc or whatever it is. It's not too much. It's just the right amount of time that I'm willing to make the travel and go do it. And Twitter has offered to host, which I think is also, it's like, for us, it's not too far, you know, and this just seems like a good way to get together. And
yeah, I think like distributing the hosting to other companies is great.
Yeah, we could distribute it. That oh, you mean beyond just Twitter too?
No, I'm just saying the fact that Twitter is willing to host is awesome.
Yeah.
Maybe could do it.
I'm sure they would.
Yeah.
I'm sure they would. So, we like it?
Yeah, why not?
Anybody who's on the call remotely have an opinion about it?
Andrew's like, Microsoft will host.
It could happen.
Awesome.
And you'll buy us all flights up there?
See, that's where the idea might break down.
You guys fly first class, don't you?
No, we don't actually, sadly. I tried once, didn't happen.
Cool. Okay, so the next one I think is scheduled for February 15th. So
Oh, that's right, because these are only monthly.
Yeah.
So every other one is literally
It's
like
every
8 weeks.
2 months, yeah.
That's probably a good place to start. I like that.
Yeah, I think that's very like possible.
Yeah, for some reason I was thinking it was like a weekly meeting.
That would be a lot. So February 15th will be the next one at Twitter, or is it going to be here?
Let's do it Twitter.
Okay, great. Cool.
And we'll work with me and we'll coordinate and get them all
All right.
connected. Okay.
Cool. Great.
Who's hosting?
No one's here right now, but they said that they
So
wanted
excited.
to host. All right. So the second item was, I thought it would be fun to just talk through the 1.5 features. A bunch of you guys have probably all done this, but it's just always good to do it again. And then G, you've got a
Yep, I'm here.
got a blog. You got a blog going. I thought you could just pull up the blog and share the blog, and then just walk through the feature. And if someone isn't here that can talk enough about the feature, they could briefly just mention something about it. And then it's also a good way to remind people that they need to finish filling in the blog so we can publish.
Can you guys see my screen?
Yep.
Yeah.
Okay. So this is the draft. Kind of like kind of nagging people trying to fill in the section for each of the new features or improvement we have done in 1.5. So this is the entire doc right now. I think I kind of like classified the new features into a bunch of category like cluster operations. We did add this agent reconfiguration policy improvement so that you don't see this nasty error again once you change some of the resources on agent flags or environment variables. Do you want to talk about that?
Regarding about each of the feature?
Yeah, just like not in detail. I think you just give a quick
overview. What is that? I don't think everyone has the context here.
Got it.
And people can watch it later too.
Yeah. So I guess the
the thing we did in this feature was previously when you made any changes to the agent configuration that deals with resources or attributes, for example, we always used to flap. Like any changes to resources or attributes, we used to flap, and the remedy that was logged out was something that looked like that, where we recommended people to do rm-f of the meta directory. So we kind of relaxed that constraint right now in 1.5, where we are saying if we add this new flag called reconfiguration policy and give it a value called additive, we allow you to add increased resources or add new attributes without having to make the agent flap. So agent kind of smartly deals with that. It properly updates its own state, and it properly tells the master to update its own state so that everything works properly and you don't need to restart the agent anymore. So it's been a long requested ask from the community, especially to change. So we're halfway there by allowing the increase and addition, like allowing it to shrink, and removing it was a little more tricky, so we didn't handle that yet. But we allow expansion and addition, so it's going to be really useful for people.
Right, sounds good. Thanks, Vinod. So yeah, so that's the under the cluster operation category, and the other category we did is that we improve in 1.5 is storage. So I haven't write the section yet, but I'm planning to, and I have a demo later in this meeting, so I can show you the feature, the CSI support. The other category is containerization. So I'm not sure if Gilbert is on the line, but we did some change to the Mesos containerizer so that we can support like dynamically garbage collect those unused Docker layers. It's also contributed by Uber folks on this. So it's a very useful feature if you're running Docker containers in production. Part of the storage work, we also add some feature to the containerization stack. We call it standalone container. So right now, like you can launch a container in Mesos without go through the normal offer cycle. So Joseph, do you want to briefly talk about that?
Yeah. So this new API is sort of meant to bridge a gap between well, let's see. I guess it's meant to support a few things in the future, but for now, it's just for the storage work that was also, I think, listed on this doc. In the future, we can probably use this for launching things like container daemons. I mean, daemon tasks on every node, and other admin tasks like that. For now, this one is sort of like a work in progress. We don't expect people to use this too often.
So the idea of standalone container is those resources.
Vinod, you're cutting off. Can you repeat the question?
I was saying with the standalone container, how are the resources accounted for the standalone container? Does the agent
yeah, at the moment, the resources are not accounted for. That's actually future work.
Okay.
So it's possible to overcommit or, yeah, overcommit.
Got it.
What's the plan in terms of resource accounting?
So there will always be a possibility for overcommit, but at some point, the standalone container resources will basically be subtracted from the current set of resources, and then that'll be reported to the master.
Okay.
And I think that we make it easier if since we have this update slave message, it's very easy to like update the slave, say we have fewer resources, right?
You're saying that's easier than.
Then before we just need to report all the resources during registration. So now we have this new message.
Yeah, I think I'm not super worried about overcommit issue, because if you look at those system D unit that we run on every single machine, it's overcommit too. So I'm not super worried about that thing. Like I think one thing we can do is like we reserve a pool of resources that's dedicated for system daemons, and then using and making sure that the standalone container are using those resources. That's not touching, and it's not touching like task resources or executor resources. Okay, I think we can move forward. So that's the containerization improvement we've done in 1.5. It's a lot of feature that we added. And regarding like resource management, we did a bunch of improvements for that too. So one thing is the quota guarantee improvement that Man and Ben Mahler and Park have been working on. Do you guys want to talk about, like briefly about the improvement you guys did?
Yeah, I mean, there's a bunch of specific tickets that I think are listed in the actual changelog, but in terms of the blog post, I just wanted to highlight it here because the user experience is improved. So when you set guarantees, we do a better job at making sure that you actually get those guarantees, and we do a better job enforcing that that amount is your limit as well, so that you don't exceed it. In the past, there are several scenarios where you might not get it, or you might be able to exceed it, that we've fixed in
If you
1.5.
want to put a little more here, it almost sounds like it's just a reference.
Yeah, I don't know. I mean, what would you want to see here?
Well, I guess what's in the change log that you're referring, just a ticket there? Or is it more?
4 or 5 tickets.
Maybe if there's like 1 or 2 tickets that are particularly notable.
Yeah, we could have a bulleted list maybe of like specific little
Yeah.
summary of each case or something like that.
Like reservations are properly accounted, and then stuff like that would be nice. Just to get a high level, this one just says some made improvements and the change log.
Right, that's a nice follow-up. And I think around the other side of the improvement we did for resource management is like we introduced this new notion called resource provider. Like right now, using this abstraction, you can customize the providing part of the resource. You can customize that part. So basically, like right now, if you think about Mesos agent itself is a resource provider, but we don't have a way to customize that. It has to be hard-coded in the agent code. But with this abstraction, you can now like customize like when to send out more resources and how to handle the operation on those resources. And the main motivation for this new abstraction is for the storage work. Like we want to customize the disk resources specifically, but the interface itself, the abstraction itself can be reused by other type of resources like network bandwidth, IP address, things like this in the future. Or devices, GPUs, whatever. So that's something that we add in 1.5. It's experimental. There's an API that we expose, which is similar to the framework API, that people can write on their own in resource providers. But we do provide some default resource provider for the storage work. The other category is performance improvement. We did a lot of performance improvement in 1.5, and Ben, Man, do you want to talk about this?
So I'm going to show the result after this.
Okay, great. So you have a result for some performance improvement. That's great. So yeah, let's skip this for now. And I think Andy is on the line. So can you briefly talk about the Windows improvement that we did in 1.5?
Yeah, if I can find my unmute button. Honestly, it's a little hard for me to say just because we didn't have like a 1.4 baseline. I don't think we put together even release notes for the stuff that went into 1.4 for Windows, but most of what we fixed in 1.5 is actual support for most things. Like coming in from 1.4 to 1.5, we had the Mesos agent working. Like it could launch tasks, but you didn't have any sort of isolation. So sure, you said max out at 1 CPU. There was no enforcement of that, even though we had job objects in there. So one of the major things here, I worked with G to actually implement proper isolators on Windows using the job object. So we're speaking not of Docker containers, but just like launching raw commands on the machine. This is sort of like what you have with C groups on Linux. It's as similar to an API as you can get on Windows, although big difference is that it's like an actual hard cap. But these now work. You can specify a limit on your CPU and your memory usage for a particular task, and that's actually there and enforced by the OS. So that's fixed, well, implemented now. Also in 1.5, we have the fetcher working. That was just not part of the build on Windows yet. So the Mesos fetcher, of course, you all know, give it a URI, it pulls it down. We've got support for zip files, and then to automatically extract those, and then whatever else. It doesn't extract tarballs, but anything else it'll just download. We would like to add like better support for extracting, you know, any arbitrary thing, but right now it just uses PowerShell, and over on Linux we just also shell out to stuff. I think in the future we should use something like a like a 7-zip library to just extract everything in process without having to shell out and depend on Linux stuff. On shell utilities. But yeah, that works. It works over HTTPS too, which was kind of annoying to solve because we were using curl, which the older version used OpenSSL on Windows. And while that works, you don't have certificate bundles on Windows with OpenSSL. So we upgraded curl, and now it does just work because it uses Windows SSL libraries now. So that was a big thing that got in. I don't think the Docker health checks got in, and now I'm going to just read this thing in front of me to remind me what else we did. Thanks for having that. Oh, yeah, long path support is here. I don't know if this was in 1.4 or not, but I think some of it was. But for the longest time when you ran the Mesos agent on Windows, you had to do a whole bunch of upfront fixes on your machine to enable like Windows long path support. You had to go change a registry setting or group policy stuff just to make it so that the agent would work. We fixed that. We took CMake's route of any path that we're given. We prepend this long path prefix, which is information that the Windows APIs use to say, oh, we're actually going to support long paths here, so greater than 255 characters, and it just goes straight through the API to NTFS, which has always supported long paths. This is a Windows API problem, but all of that is fixed at like the base layer inside of Mesos. Anytime we make a call to a Windows file system API, it gets tossed through a little long path abstraction and just works. So you don't have to set a registry setting, you don't have to set a group policy. The Mesos agent can just be installed and work on Windows now. So that's nice. I don't think we have installers yet, but for the most part, like, it's coming along. I think we made some significant progress on it. The next stuff that's coming up that's not in 1.5, but is like features coming out of 1.5 we're working on is agent recovery to actually work. Literally debugging that when I alt-tab from this meeting. And health checks for Docker containers as well. Those are actually up for review. So those are some upcoming features. So yeah, that's Windows.
Great. Thanks, Andy. This is great. Yeah, so this is a Windows support, and the last category, it's just like a feature. Like we did some improvement on the replicate log itself. That gives you some. I think Ilya is not on the call, but I give you some context on this improvement that we did. So previously, first of all, for those of you that are not familiar with what replicate log is, it's used by registry to store state in Mesos master. And also it's used by Aurora to store its state. It's based on Paxos. And previously, only the leader can catch up with the rest of the followers. But that caused me issues, especially when it wants to do a failover. Like for example, Aurora Master wants to do a failover. It takes a lot of time for the follower to catch up with the leader once they become the leader. So this improvement actually allow us to allow a follower to do catch up with the leader while it's not leading. So that it can just basically just catch up and fill those holes in the replicate log if it could. And once it becomes the leader, it will take much less time to become the leader because it don't need to fill a lot of the hole inside the replicate log. So that's a huge improvement to the replicate log library that used by Mesos and Aurora, some other applications. Yeah, I'm gonna nag Ilya to write some text for that improvement. I think the documentation has been published, but we haven't read the blog post yet. Okay, that's pretty much it, the entire blog post so far. If you have any new features or any improvement that you want to add to the blog post, let me know, and I'll just add a section there.
Sweet.
Awesome.
Cool.
Okay. Let's switch to now getting G and Meng to discuss those pieces that they said they were going to show us demos on.
Okay. Let
Thanks,
me
Mike.
share my screen first.
Are folks pretty excited about 1.5?
I'm excited about garbage collection.
In UCR?
Yeah, I
Where's
hear
Gilbert?
about that a lot.
Okay.
I am too. For lots of reasons. One of the biggest ones is I think that was one of the last ones that kept a bunch of people from choosing to use it instead of Docker for production. So that's awesome. All right.
Okay, so I will talk about some of the performance benchmarking and improvement result in 1.5. So the background is that previously there are user reporting that the V1 API, the performance issues with V1 API, and specifically comparing to V0, it was much slower. So we go ahead and benchmark ourselves and pick up some low-hanging fruits in performance improvement. So what this results shows are basically the performance difference between different API versions and different Mesos versions. So these tests are conducted on MacBook Pro with Intel Core i7 3.3 gigahertz processor and 16 gigabyte of RAM. And we build Mesos with optimization enabled. So here are the results, which comparing the performance of different APIs, specifically V0, V1 protobuf, and V1 JSON. So what we did is we set up a bunch of dummy agents and tasks, but with actual states, and we will call the get state endpoint to build up the response. So here are the results. These are the normalized average results comparing to the V0. So as you can see in...
And when you say average, you mean across 1,000 agents, 10,000 agents, 20,000 agents, or across many yeah, that must be what you meant.
Oh, it's just between different setups, the normalized.
Okay. Sorry, just quick clarification. Did you run, like for the 1,000 agents, I mean, you ran this a bunch of times or just ran it once?
Just ran it once, I didn't repeat.
Okay. Go on. Yep.
Yeah, so so we normalize the performance to V0. As you can see, the in version 1.3, V1 protobuf is roughly on par with V0, but V1 JSON is much slower, like 7x slower comparing to V0. And similarly in version 1.4, it's also the same result. V1 is similar to V0, and V1 JSON is much slower. And jump to version 1.5. So we did some performance quick improvements. So now the protobuf version is even faster than V0, so 38% faster. And V1 JSON is also recovered much. So it's only 1.6x slower than comparing to the V0.
Do you want to talk about the performance improvements?
So those are some low-hanging fruits. Specifically, we eliminated a lot of copy in the C++ code, and we use move semantics to construct the states. So that are the performance improvement for the V1 protobuf, and also for the V1 JSON as well. And for JSON specifically, we use mparks JSONify function to avoid constructing an extra JSON object and use that function to directly serialize C++ object directly to the bytes.
What was left that wasn't JSONified?
It was calling JSON protobuf directly, the old function. I didn't know about it, so we just changed that to a capital P and then threw it into JSONify, and then it's. We should actually do an audit of like the existing. I actually haven't done it yet, but.
So that was going to kind of be my follow-up. Do we see, is this a repeatable benchmark we can keep running so we can kind of watch this for each release and see, Does it creep from 165 to 18, 112, 30?
Yeah, I was thinking about that. Yeah, we can set up like CI, performance CI.
Yeah.
Is this all part of the benchmark suite now? Is it part of our test?
It's checked in. What do you mean by performance benchmarks?
Like this benchmark, are they run as part of the make test benchmark? Or is it just out of band you ran this stuff?
No, it's checked into the
It's checked in, yeah.
Check in the master.
Yeah.
Okay. Just need to figure out how to get this metrics and graph. And then
Yeah. So this tab is just a rehash of the previous data, which compares the performance, how the performance changes across different versions with the same API. So for V0, it's mostly the same. With V1 protobuf, we make some improvement in the 1.5. And even for JSON, the improvement is even more significant.
Sweet.
Yeah, that's all I got.
Random blog post?
It's already written, isn't it?
Nope.
The performance working
There's two things. There's this one that Meng did, and then the other one that Ben wrote the blog post on was on master.
Oh, failover. Okay, cool.
That's pretty darn good. 7 to 1.65. That's a good speed up.
Yeah, we should definitely mention that in the release blog post, and probably have a dedicated blog post for this.
It's almost like
You don't want to tell people?
Yeah, it's like really like I didn't use JSONify until it's dumb, like really slow. Like, do we even really want? I like don't even want to tell people, honestly.
I think it's a
How about
beautiful
this?
story.
How about this in part? Let me ask you two questions. One, how many people in the Mesos community that are hacking know what JSONify is? How many people in this room know what JSONify is? What MPark did with JSONify? Does everybody know, like, to deep detail?
I only know it from the build system.
I know the build system. All right. So already, my guess is I think this is one of those things where you're like so in it that like already telling people like it's included in part of this blog post, the discussion about JSONify. It's actually valuable just for the Mesos community. And then JSONify itself, I think, like making the blog post also incorporate a discussion about JSONify is valuable for the rest of the world. Like, hey, we did JSON in a different way. We got these crazy cool performance speedups. Like, we don't have to just be writing about Mesosphere. We can be talking about just generally interesting stuff. So, to me, there's a great quote I heard the other day, like, turn every crisis into an opportunity. This crisis of, like, we don't even want to tell people, I think we can turn into a great opportunity of, like, actually, we got this cool thing called JSONify. We've never told the world about JSONify. Let's do it in a blog post.
Yeah, in fact, yeah, protobuf itself has a JSONify, like convert protobuf to JSON. So it would be nice to compare that, see what their performance is, and see if we're doing better than that. So Proto 3 has that native JSON, protobuf to JSON conversion function.
It's in Proto 3.
Proto 3, yeah.
You're using 3, right now?
Yeah.
We are using Proto 3. I mean protobuf 3, but some of the protobuf is Proto 2 syntax. Some of the protobuf is Proto 3 syntax.
Yeah, sounds like there's some code that can be deleted in Stout, though.
I don't think so right now, just because our conversion is different than their conversion.
Oh, they've made a different JSON choice of like how to do like false and true or labels.
Default value, right?
There's some slight differences there. We need to figure out what to do about them.
Yeah, there is some slight difference, especially like how do you translate underscore to like, for example, if the field is like snake case, I think they translate that into like camel case for the JSON. Something like this that we don't do.
Oh, really?
Yeah. So there's a convention in protobuf that if the field is snake case, the JSON will be the name will be camel case.
I think that's an option that you can toggle.
Yeah, I think that's an option you can toggle. I think, but I'm not exactly sure.
Okay. All right, I closed my laptop and we should keep moving because we are at 3:40.
Yep.
Okay. So I have something to show.
Hold on, G. Ben had a question.
I was just gonna say I added the list of things if you wanted to hear about them or not. We could talk about them.
That we did
for quota and stuff. Yeah.
Oh, sure. If you want to
Otherwise,
hear.
we can keep going.
One of the features is especially exciting for me.
Yeah. let's hear
I
it.
guess we don't have the agenda up.
G, can you pull up the agenda real quick just before you talk about whatever else you're going to talk about?
Hello.
Oh, okay. I was thinking about the blog post, sorry.
Change it log.
The blog post, do you have the blog post?
Oh, okay. The blog post. This one. Oh, sorry, not this. Oh, yeah, this one.
The first one was that in the past, it used to be possible to amass reservations, because when you left a reservation unallocated, we didn't realize that that was going to be allocated to you, and therefore we should probably take that into account for your quota. So you could kind of make reservations, leave them unallocated to keep declining them, and keep building up lots and lots of reservations, and then start using them when you're way over your quota. So that's been fixed. The second one is we used to do core screened allocations. So if you had like one CPU quota, but the box has 24 cores, we'd give you 24 cores. So that's been fixed.
That's what I'm really excited about. Because we've seen at users, they have these giant boxes, like 64 core boxes, and they'll get allocated out to something initially. And the systems, like say Spark, doesn't know that its quota is only one core, and it just get offered 64 cores, and it's like, oh sweet, I can launch 64 drivers. It's got a big queue and it'll launch 64 drivers, and then the system would be way over quota. So I think that's a great one.
I think the third one is just this bug that's kind of always been there that Meng noticed when we were writing some of this code, where you sometimes won't receive a reservation if you don't have quota. Just the way the code was written.
Yeah, the problem is a headroom calculation. So if the quota is unallocated, we need to hold back headrooms for those, and as a result, we might get some reservations unallocated.
Because we broke the loop earlier. So.
Yeah, right.
Okay. The next one is, there was a case where like if you had more reservations than your quota, we computed the headroom not realizing that those reservations should only count towards your quota. We kind of counted those reservations towards the total sum of quota, and as a result, we would sometimes compute less headroom than we really needed. Mm-hmm. Like if Greg has 1,000 CPUs reserved, even though he has 10 CPUs of quota, we shouldn't just subtract 1,000 reserved things from the overall quota pool. We should just realize that, okay, it's only Greg's quota that's affected by this reservation. So that's been fixed. And the last one is, when we're allocating to a role for quota, there's resources on the box that they have quota for, and then there's resources on the box that they don't have quota for. For example, ports. You can't even set quota for those, right? But there's also resources like, I don't know, GPUs that maybe you didn't set quota for, and there's a question of should we give you those resources or not. In the past, we always gave you those resources. We just included them. But of course, that might violate someone else's quota. And so now, before we make that decision, we look at what is the headroom needed, and are we able to give this out without violating that? Right, so if the node had one GPU quota, and I'm giving something to Greg, and I see that I need one left for headroom to satisfy the node, I wouldn't give Greg that GPU. I would leave it for the node.
We also take into account the fragmentation for non-quota resources. So if you have non-quota, if there's non-quota resources on this agent, we only allocate to if you have also some resources on this agent. For example, it doesn't make sense to allocate port resources for you if you have no other resources on this agent.
Mm-hmm.
Cool. Fragmentation.
Yeah.
So hopefully the user experience is better.
Yeah. Sweet. Great. Okay. G, CSR.
All right. Thanks. So I'll start with I don't have a slides, but I have the documentation. So I can go through the documentation to give you an idea of what that is, in case you guys don't know about this, and do a demo in 5 or 10 minutes. So this is the architect. So the reason we want to do this CSI support is there's like a couple of limitations for the storage support in Mesos, mainly like for local persistent volumes. First of all, we don't offer like logical block device or physical block device directly. And we don't have a way to allow framework to make a choice on the disk they want to choose. Like I think some of the frameworks are very opinionated about like which disk they want to pick. Right now, there's no way that they can tell which disk, like what's the attributes for that disk, things like this. They can just pick the disk based on like, for example, like size, which is not very reliable. And it's a big burden for operator to configure each agent manually to adding disk or removing disks and making that very inflexible. So that's the part of the local persistent volume. That's kind of something that we want to improve for local persistent volume. And we do have some limited support for external persistent volume in Mesos. It's go through Docker volume driver interface through an isolator in Mesos containerizer, but itself has a lot of limitations. I think it's documented somewhere, and I think the main reason that's not reliable for that thing is because the interface, Docker volume driver interface itself, is not very well designed, such that, for example, like things like, for example, some interface is not idempotent. It might leak volumes if you lost the response from the plugin, something like this. So, and also I think more importantly, it's an isolator. It don't account for the resources used by those external disks. So, so basically, the external volume support right now in Mesos totally just bypass all the resource management part, which is not something we want. We want Mesos to be aware of those resources and then do fair sharing, quota allocation on those resources. So that's the reason, kind of the two motivations that drive us to do this work. And I want to briefly talk about CSI and the interface. There's a collaboration between like major container orchestration system like Kubernetes, Docker, Mesos, Cloud Foundry. The goal is trying to create an interface so that the storage vendors just need to write one single CSI plugin, and that plugin can work in any of those container orchestration systems. So that it's really nice for vendors because you don't need to duplicate the effort. It's also good for us because we don't have that interface. We need to create one, and better to create some interface that can be shared by multiple container orchestrators. So that's the context. So here is the architecture, how we implement this CSI support. So if you look at Mesos master and agent, so the key concept we introduced is called resource providers. So resource provider allow you to customize the resource providing part of the Mesos functionality. And the resource provider can, for example, the resource provider, like I call like storage external resource provider, storage local resource provider. These are the acronyms for those resource providers. So the resource provider connect to either Mesos agent or master directly, depends on whether they're a local resource provider or external resource provider. So local resource provider always connect to the agent first, because the resource it provides is local to that agent. And there's a manager inside the agent to manage those local resource providers. And for external resource provider, the plan is to add the same manager in master, and the manager will handle those external resource providers. For storage, basically the storage local resource provider will use gRPC to talk to the CSI plugin to get necessary information to send out resources. For example, one thing that the plugin needs to do, one thing that the Slurp needs to do is to ask the plugin, tell me the capacity of this storage system. And then once the plugin reply with a size, the storage local resource provider will basically construct the resource and tell the Mesos agent, here are the new resources that you want to send out to frameworks. That's basically how it works. And the CSI plugin itself is running as a standalone container, as I mentioned earlier. And it's managed by Slurp. So there's a component inside storage local resource provider to keep the standalone container running by hitting agent APIs. Any question? No. All right. So yeah, I think the main framework API that we did is to add these two new types to disk info. One is called block, one is called raw. So block means like it's a raw block device. It's like something that you cannot assume there's a file system on it. And raw means it's either capacity, raw capacity, or a raw volume. You haven't decided whether you want to use that as a mount volume or block volume or pass volume. So these are the new types that we introduced in 1.5 and that the framework can use. Whenever you have a storage pool, like for example, LVM volume group, it has like 10 terabytes of disk space, and then Mesos will send out a raw disk resource with 10 terabytes, and the framework can do operations on that raw resources to either convert that into block or convert that into mount or pass disks, and then use that as part of the task. And there's some additional field we add into the disk source to map to CSI volume ID and the attributes. You're gonna see that in the demo shortly. And as I mentioned, like a raw resource can either be a storage pool or a pre-existing disks. And pre-existing disks, we use the list volume CSI interface to discover those pre-existing disks. And then we add some new operations to the framework API to allow framework to convert a raw resource into mount volume or block volume or pass volume. So these are the new alpha operation that we introduced. Okay, so I think that's pretty much it. I want to jump into the demo. Oh yeah, but before I jump into the demo, so one thing I want to mention here is the concept of disk profile. The reason we want to introduce disk profile is because we don't want the framework to make a scheduling decision based on like storage vendor specific parameters. It doesn't make sense because like if the operator switch a vendor, the framework has to be changed to deal with new set of vendor specific parameters, which is not very extensible. So the idea here is trying to provide an indirection. So basically, profile is just a simple string. Just think about that as fast, slow, gold, and you can map that string to a set of vendor-specific parameters, and the framework can just make the decision based on the name of the profile rather than the specific like vendor-specific parameters. So that can so that's how people can abstract away those specific low-level details of the disk and make scheduling decision based on some high-level concept, which is called profile here. And here we introduce a module interface, allow you to customize the mapping between the name and those parameters. And then we provide some default module that's very easy to use. I'm going to demo that too. All right, so that's pretty much it. I think let's just jump into the demo. Let me share my terminal. Hold on 1 second. All right, so can you guys see my screen?
Yeah.
All right, so what I'm gonna do is, this is on my virtual machine. So what I'm gonna do is, I'm gonna start, so these are the commands. So I'm gonna start a master first. These are just a regular master. I'm just gonna start a master first. This is the 1.5, latest 1.5 master Mesos. And then I'm gonna start an agent. So this is the agent. So there are like some new flag that I need to use. One thing is like resource provider config. So that flag will point to a directory where you can put those resource configurations in that directory so that Mesos will load those resource provider. So you pre-config that into, it can be an empty. I'm going to talk about that later because we can add the resource provider dynamically through hitting an agent API, operator API. And this is the profile plugin that we're going to enable, which we ship with Apache Mesos, open source. And it's going to do the translation from profile name to a bunch of vendor specific parameters. And then these are module directory. And then you have to enable this agent feature called resource provider to be able to use that feature. So let me run the agent right now. Okay, so if you go to Mesos master, you can see it's running. Agent is running too. Agent is registered. Okay, now what I'm gonna do is there's some command. So this command is gonna use the agent API, operator API to add a resource provider. So it basically take this JSON blob. Let me open that JSON blob. So what this configuration tell? Hello. Any question? All right.
We didn't see the command.
Oh, you didn't see the command?
Yeah, right now it's doing it.
Okay. Yeah, so these are the JSON block for the agent operator API call. So basically, we have a new operator API call add resource provider config, and then you specify the resource provider info, and then you specify the type on the name of the provider, and then you can specify some dynamic reservation, default reservation you want the resource to have. It's okay to leave that empty. If you leave that empty, then the resource that the resource provider send out will be unreserved, but you can pre-reserve those resources. And then for storage specifically, you need to specify the CSI container. For example, here we have one CSI container. These are the commands to launch the CSI container. So I have a plugin called test CSI plugin, which is very dumb, that just basically carve out a directory from a parent directory and pretend that to be a volume. And you specify resources for that CSI plugin container. And then you just hit the agent API using this to run it. So I'm going to just run that. So I'm just run that. And you can see if it's successful, you return 200 OK. And if you go to UI and you go to agent state.endpoint, you're going to see that, oh, there's some new resource being sent out. It's reserved to test row, and it's raw. It has a provider ID. It's coming from that resource provider. And it has a profile, example profile, that's basically translated by the module that we ship with Mesos. Okay, so that's the very simple plugin. What I'm gonna do next is add a different plugin. So there's another CSI plugin called devices plugin, which basically does listing, basically just lists all the route block devices on that box. So if you do that, you get 200 OK2. If you go to stay and just refresh that, you see there's a different set of resource being sent out, which is the route devices. And actually, this plugin will set some of the attributes for each route block device, basically the output from LS block. So you can see what's the type of the disk, what's the size, whether it's rotational, SSD, or what's the model, things like this. Though these are going to be route resources, and the framework can decide to use that as a mount or as a block device. Any question? Okay, so now I'm.
It's very
Hello?
cool, G. Go on.
Yeah. Okay. So one last step. What I'm gonna do is I'm gonna launch a framework that consumes those resources. I think this framework is committed inside Mesos already. It's an example framework that written by Benjamin. What this framework is going to do is it will receive route resources and then just reply with create volume to create a mount disk, and then unreserve that resource mount disk so that other framework can receive those resources. So I'm going to go ahead and launch this framework using Mesos execute. All right, so I think this framework should be running. We can check that. Yeah, so this framework is running. And if we go to the state endpoint, and you can actually see that the disk resource we see earlier, it's a route resource, 2 gig, was actually translated into mount by that framework. And then these are the same mount disk that other frameworks are using. So basically, the other framework can just take that mount disk and then launching their Cassandra Kafka tasks on that using that mount disk. And this disk has an example profile, as I mentioned earlier. So these are the kind of the whole demo, right on time. We have 2 minutes left. Any question? Any question?
No. Questions?
I guess what's getting shipped with Apache Mesos, like in terms of the CSI plugins, what sort of plugins are you shipping?
Yeah, so that's a good question. So we ship a plugin. Let me give you, basically the plugin just take a JSON. So that plugin just simply take a JSON. It's called profile matrix. And then it's a mapping from profile name to a bunch of volume capabilities and create parameters. In this case, the parameter is 0 because it's a test plugin. And then you can specify access mode and mount. Those are the CSI concept. It map 1-to-1 to CSI volume capabilities. and people can just add in those new profiles to that JSON file. And then the module itself will pull in from either a file or a HTTP server. So you can host that profile somewhere in the cluster and in Nginx, for example. And then the module will just pull in those profile matrix every 10 seconds, for example. You can configure that. And then the profile will be updated. So once you add a new profile, there will be a new route resources with a new profile show up, and then framework can consume that. Depends on whether the underlying CSI plugin support that profile. Yeah, so everything you saw here is open source Mesos. Yeah, I did the same demo last time in a containerization working group using DCUS, but I thought this time I'll just try it with vanilla Mesos, see if that works. Yeah, sounds like it works.
There's a lot of people in this room that also worked on various parts to make that work. So it's really great to see this all come together. Lots of different pieces. It's pretty cool to see them all come together. And
yeah, and huge thanks to everyone who is involved in this project. It's a very big project, the biggest so far, like at least my experience. And yeah, huge thanks to those guys. And there's a lot of improvement we need to do. This is just MVP. I think the eventual goal we're gonna get to external volume and global resources. That's the eventual goal we wanna achieve. But this work did some groundwork to make that easier.
Well done, everybody. It's awesome. Cool. All right. Thanks for presenting, Ji and Meng, and see you guys at I think Twitter in person.
Did we get through the agenda?
Oh, there was one more thing on the agenda, which was I wanted to get MesosCon feedback, in particular as we're thinking about the next MesosCons. One of the things that we're thinking about is having like an even lower level focused, I don't know if you want to call it a track or a Mesos plumber-y kind of. So right now, because the conference is getting pretty broad, there's like a lot happening. And the feedback that I've at least gotten from the last conferences is great conferences, but there's some talks that there's really high level and there's some talks that are super low level. And there's some people that only want to come to the low level ones and some people that kind of want to do a mix of both, but whatever it is. But the people that only want to come to the low level ones, we're thinking about actually having a specific event more focused on that crowd. And I just love to get feedback. So
by lower levels, I mean our internals track or?
Well, that's kind of what we tried to do at the last conferences was do an internals track. I would say the lower level track would be not just internals, but also like things people have done on or around the project. So like Yelp or Twitter talking about some of the things that they've done on or around would also be considered sort of more low level, whereas the higher level stuff would be things from, say, partners talking about some of the integrations they've done on top, or some of the projects that they run on top. That's it. Perhaps the best way to describe it is there's like a Linux plumbers con, which is more like what I think all of you guys would go to if you went to if you wanted to go to like a Linux con kind of thing. And then there's like Linux con. And we're trying to get feedback on whether or not we think it would make sense to be more explicit about the separation. The answer could be we don't talk about now. Just if anyone wants to share, you can email me. The answer could be, oh no, it's a good balance, or the answer could be, yeah, I felt the same thing, and I even heard feedback from certain people at the conferences. Or the answer could be, actually, I think we should do even less internal detrack stuff and do even higher level stuff. I just love to hear people's feedback. If you wouldn't mind sharing, that would be great. Email, snail mail, store delivered mail, any of that works for me. Carrier pigeon. All right, sweet, thanks.
Cool, thank you guys.
Thanks, guys.
Ciao for now.
Bye.
Bye bye.